Final review, question number 4. Find t for the following terminal points where t is between 0 and 2 pi. To answer this question, we will need the unit circle. As you can see here, I sketched the unit circle. And all you need to know is actually just the first quadrant, and then you can figure out the rest of the points. So here is the unit circle. This is angle 0, and this is pi over 6. This is pi over 4, this is pi over 3, and this is pi over 2. The first point here is 1 and 0, the second point, the third point, the fourth point, and the fifth point. The fifth point is 0 and 1, and the first point here, I'm gonna create fractions with the denominator of 2, and then I will go 3, 2, 1, and then 3, 2, 1, and then I'll put the square root on the numerator. If it's a 1, square root of 1 is 1, so there is no need to put a square root there. So this is how you're gonna memorize the first quadrant, basically, and then you can figure out the rest of the quadrants. So the first point, P is 1 and 0. As you can see, this is this point right here. So the angle T is going to be 0 radians. The next point is square root of 3 over 2 and 1/2. This is basically this line right here, which leads us to the angle pi over 6. The third point is 0 and -1. 0 and -1 is right here. As you can see here, we have pi over 2, and this angle is basically 1 pi away from that angle. So if we add 1 pi to pi over 2, we will get this angle. So if we do that, we get 3 pi over 2. So this is 3 pi over 2. Next is negative square root of 2 over 2 and negative square root of 2 over 2. So I know that square root of 2 over 2 and square root of 2 over 2 is this one right here. Now, in order to get this point is actually in the third quadrant, so it's right here. As you can see, it's a straight line from this line right here, which means if I add 1 whole pi to pi over 4, I can reach to this angle right here. So if I do that, I will get 5 pi over 4. So the line is going to be straight from this point, and it's going to be negative square root of 2 over 2 and negative square root of 2 over 2, because it's in the third quadrant. Next point is negative 1 and 0. Negative 1 and 0 is right here. And as you can see here, here is 1 and 0, and here is negative 1 and 0. So if I put 1 pi plus 0, I will get this point. So the angle that corresponds to that point is pi. Last but not least, negative 1/2 and square root of 3 over 2. Basically, that point is similar to this angle right here, which is pi over 3. But because the first coordinate is negative, it is going to be in the second quadrant. So it's going to be right here. Notice how this distance or that angle is similar to that angle, but in the opposite direction. So in order to figure out the angle that corresponds to this line right here, which corresponds to the point negative 1/2 and square root of 3 over 2, by the way, we can say 1 pi minus this much or that much, which is basically the same in radians. So it's going to be 1 pi minus pi over 3, which is going to give me 2 pi over 3. Or you can figure out the rest, and then all you need to do is just to match the points to the angles. Next, without using a calculator, find the exact value of each expression. So notice how the first expression here, tangent square of pi over 4, is a number, and so is secant square of pi over 6, because these are actual angles. So What we need to do, we need to find out the value of tangent pi over 4. And then we need to find the value of secant pi over 6. And then we can plug in the values here and find the answer. Tangent pi over 4 is sine pi over 4 divided by cosine pi over 4, which is, if you look at the unit circle, it is square root of 2 over 2 divided by square root of 2 over 2, which is equal to 1. And then secant pi over 6 is basically 1 over cosine pi over 6. And if you look at the unit circle, the cosine is square root of 3 over 2. So this is 1 divided by square root of 3 over 2, which will lead to 1 times 2 over square root of 3, which is basically 2 over square root of 3. And then you're going to rationalize by multiplying by square root of 3 over square root of 3. So you get 2 square root of 3 over 3. Now, if we plug the numbers in, we get 8 times tangent pi over 4 all squared is the same as tangent square pi over 4. Same thing. So we can replace that with 1 and square it, plus 15 times 2 square root of 3 over 3 all squared, which will lead us to 8 plus 15 times 4 times 3 over 9. And that will lead to 8 plus 15 times. We can reduce the 3 with the 9, and we can reduce the 3 with the 15, so it's 5 times 4, which will lead to 8 plus 20, and that is 28. So the final answer is 28. So the final answer for that expression is 28. We're going to do the same for this expression right here. So tangent pi over 3 is equal to sine pi over 3 divided by cosine pi over 3. If you look here, sine pi over 3 is equal to square root of 3 over 2 divided by cosine pi over 3 is 1/2. That will lead to square root of 3 over 2 times 2 over 1, which will give us square root of 3. Secant pi over 4 is equal to 1 over cosine pi over 4, which is equal to 1 over square root of 1 divided by square root of 2 over 2. And that will lead us to 1 times 2 over square root of 2. And that will lead to 2 over square root of 2 multiply by square root of 2 over square root of 2 to rationalize. And then we get 2 square root of 2 over 2, and that will lead to just square root of 2. Now we're going to substitute. So let me just highlight what we found. And now we're going to compute 6 times tangent square pi over 2, that is square root of 3 all squared, plus 12 times square root of 2 all squared. And that will lead us to 6 times 3 plus 12 times 2. And that will give us 18 plus 24. And that will give us 42. So that is the final answer. 42 is the final answer for that expression.